Okay, we're jumping to seminar sheet 5 here. What we're going to do is we're going to have a look at this design. We're going to design this system. We could design all the values of every single component inside here. What we're really looking at doing inside here is working out from the small signal equivalent model what our equations for each of these terms are for Vin, for Vout, and for AV. Well, first off, we need to draw out the small signal equivalent model. First note to make is that we have a collector bypass capacitor, therefore this component, RE, is effectively short-circuited from our model. So we only need our transistor and the emitter is connected to ground. So let's draw the model of our small signal equivalent transistor. Okay, we have something like that. Down here we have IB beta, and in coming in here we have IB. This term is RBE, so our current source is generating signal. We need to know what's happening with the RC component. Collector is connected to the supply through the resistor. The supply is short circuit in effect through to ground. So in effect we have our collector load resistance just here. Okay, there's our collector, and this is our emitter in effect. Our input is formed by two resistors, this resistance here and this resistance here. So in effect, from the basis perspective, we're connected through two resistors in parallel. So let's put those components on. So this is R1 in parallel with R2. Okay, we now have our input signal Vin expressed across that point, and our output signal Vout expressed here. Okay, so these are our AC signals. This potential down here is effectively ground. So what we need to do now, we need to go onto the model and calculate an expression for Vin. We then need to calculate an expression for Vout, and then of course we can calculate AV. So let's calculate the first value, Vin. I'm just going to talk it through on this slide, and then we'll go through to the next slide and we'll write out all the equations. So for a start, Vin would result in a current In, okay, but which will be dissipated in the bias and then form IB. However, if we want to just be quick, we can say, well, IB multiplied by RBE will give me Vin. So our input is simple. Let's have a look at our output. Our output is forged through a current source. The current source is pulling current through the collector down effectively into ground. So around this loop you simply have this current and this resistance. So Vout equals RC IB beta. Let's go on to the next page and let's write all these equations out. Okay, I'll start by writing Vout. Vout is the easy one. IB, our base current, multiplied by beta, multiplied by our resistance. Let's write out Vin. Vin is equal to IB, the base current flowing in, multiplied by RBE. Now I don't like to stop there. I like to remember that RBE is actually equal to 1 plus beta RE. Okay, emitter resistance, and of course RE is equal to VT over IE. Okay, so in effect the resistance here and the resistance here is controlled by your current flow. Right, let's calculate our value now of AV. Okay, AV equals Vout divided by Vin. So we just substitute these values in. IB beta RC, all divided by IB RBE. Okay, straight off we can cancel IB because it appears on the top and the bottom. I'm going to go across here again and I'm going to simplify by expanding out RBE. So on top we have beta RC, on bottom we have 1 plus beta RE. Okay, now we use a bit of logic. Beta is significantly greater than 1, Therefore, beta plus 1 is approximately equal to beta. If we do that, beta and beta plus 1 cancel. We're now left with RC over RE is our value for gain. Okay? And there we go. We have now calculated exactly what we set out to for this particular design, and we've worked out our equations. One thing just to tidy up here, we should note that our current flow is inverse, so it's a negative term here. Therefore, we should have a negative 1 or a negative sign all the way along, because our output is minus RC over RE. That effectively means that if I was to draw our input signal like that, our output signal would be on some DC bias, and it would be 180 degrees out of phase or inverted. In other words, multiplied by -1. So there's our sort of V out. It would be sat on some DC level, and that might have been our input signal V in at 0 volts. Okay, capacitively coupled into the base, of course. Okay, how would you control this? You need to control the design by controlling RE. The only option you have here is IE, running the emitter current at different values. If you want to do anything more serious, you have to degenerate the emitter, okay, with a feedback component.